Hello calculus student, this is the second video for chapter 2.1. We want to find area between two curves. And in example 4, we are given sine x and cosine x. They don't tell us if f is above g, but we were given an interval of 0 to pi. So it's a good idea to sketch them because they are just simple parent function. For sine x, we know it starts from 0 and it go to pi, which is what we want, right? From 0 to pi. Technically, it would go, stop at 2 pi. You know that this is sine x. And then cosine x would typically start from 1, but go down all the way to pi. This is when it is -1. This -1 is 1. And then you go back up and end at 2 pi. So you can see that they intersect at two places from 0 to 2 pi, and from 0 to pi they intersect at one place. So we need to find out, but the area between these two curves would be, this is the area between them in the first section, and the second section would be, this is the area between them, right? Including all the way here, not this is pi already. So we want to find point of intersection. Especially from 0 to pi. You can probably tell that sine x and cosine x intersect at pi over 4, but technically we should solve it. You go to cosine x, and then if I divide cosine x on both sides, because the point of intersection cosine x and sine x are not 0, so we could divide it. So divide cosine x on both sides. I would have tangent x is equal to 1. So tangent x equal to 1 is at x is equal to pi over 4 and 5 pi over 4. If you look at the unit circle, at pi over 4, cosine and sine are both root 2 over 2, and at 5 pi over 4, they're both negative root 2 over 2, so tangent is 1. And 5 pi over 4 is outside of 0 to pi, so this is the only one that is, and the y-x, so the x is pi over 4. So our area would become this. So say this is pi over 4. The second one should be here, is 5 pi over 4. But we don't need it because we only want an interval from 0 to pi. So the area would become from 0 to pi over 4. In the first quadrant, cosine is above. So cosine is above sine, right? And then plus, dx, plus, and the second part, it will be pi over 4 to actually pi, but that part, my sine x is above cosine x. Okay, cosine x dx. So we'll do it twice. So a would equal to, so this would be, when we do the integral, is sine x, but plus cosine x, because the antiderivative of sine x is cosine x. Evaluate from pi over 4 to, from 0 to pi over 4, plus, so this would be negative cosine x minus sine x, evaluate from pi over 4 to pi. So the first one would be sine pi over 4 plus sine pi over 4 plus cosine pi over 4, that's root 2 over 2 and root 2 over 2, minus cosine 0, sine 0, plus cosine 0. Cosine 0 is 1, remember. So this would equal to root 2 over 2 times 2 minus 1. Okay, so that's the first part. This the area is very small. The second one, we would do negative of root 2 over 2, negative cosine pi over 4, minus sine pi over 4, but subtract, oh no, pi. Okay, this is pi first. Cosine pi minus sine pi is 0, we don't care. minus minus what? Oh yeah, cosine first. Cosine pi over 4 negative cosine pi over 4 minus sine pi over 4. So this would be root 2. We know this is root 2 and this is negative of negative 1 is 1. So it's 1 plus root 2. The second part, the first part will be root 2 minus 1. So if you add them together, the 1 and 1 cancel. That is, the area is 2 root 2. So that is the place where they cross in the region. So this is the one where we were just given two curves. They don't even tell us which is f or which is g. They say y equal to x and y equal to root x. So we need to sketch it. Y equal to x is a line. Y equal to root x is curved like this, right? So they do intersect at 0 and another point. So what is the point of intersection? Point of, because we were not given AB at all. So we would say x is equal to root x. How do I do it? So we would say x squared is equal to x. Square both sides. So then move everything to one side. Factor x out. X minus 1 equal to 0. X is 0. X is equal to 1. So this is actually 1, which makes sense because square root of 1 is 1. Y is equal to 1, and this is 0. So this is the point of intersection. So my area would be, what's the top one? The top one is x, square root x. So it would be 0 to 1, root x minus x dx. So root x would be 0, 1, x to the power 1 half minus x dx. So that would be x to the power 3 over 2 times 2 over 3 minus x squared over 2, 1, 0. 0, we don't care, so it'll be 2 over 3 times 1 minus 1 half. That is equal to 1, 6. So the area between these two curves is 1, 6, and you have to find your point of intersection. Find the area of the region between x squared, example 6, and 3x plus 4. So let's do a quick sketch. Y equal to x squared is this. Y equal to 3x plus 4 would be a 4 here, and then kind of like this. So 4. And so they have two point of intersection where the line 3x plus 4 is on top of x squared. So again, we have to do point of intersection. X squared equal to 3x plus 4. Move everything to one side. X squared minus 3x minus 4 equal to 0. So we can factor it as x minus 4, x plus 1 using diamond or whatever guess and check that you have. When you multiply 4 and 1 is negative 4. When you do FOIL is minus 3x. So then split them. X is equal to 4. X is equal to negative 1 is where they meet. So this would be the negative 1. This is when it is 4. So our area would equal to negative 1 to 4. What is the top one? Is the 3x plus 4 and then minus x squared dx. So just do it. So be 3x squared over 2 plus 4x minus x cubed over 3. Evaluate from negative 1 to 4. So try to do it by hand. 3 over 2, 4 squared is 16, plus 4 times 4, minus 64 over 3. Subtract negative 1. So it's still 3 over 2 times 1 minus 4, right? Because 4 times negative 1. And then add 1/3, because negative 1 cubed is a negative. So let's see. So we can just see if we can x will be 24 plus 16 Okay, it's 24 plus 16. Oh, 24 plus 16 is 40. 40 minus 64 over 3. 40 minus 64 over 3 minus 3 over 2 plus 1/3. Oh, this so well, 3 over 2 we have to do common denominator. 3 over 2 plus 1/3 would be 9. 9 over 6 and 2 over 6, so it's 11 over 6 minus 4. So see what we can do. So 120 minus 64. 56 over 3 minus 11 minus 24 is, so become a plus, right? 24 minus 11 is 13 over 6. So that would equal to 102, well, 56 times 2. Okay, 56 times 2 plus 13. 125 over 6. Okay, I just checked with the calculator. It is right. So example 7. So if you're not sure about your hand calculation, please check with F and I and T. So find the region between y equal to e of x and y equal to e of negative x in the interval -1 to 1. Okay, so y equal to negative x is this kind. This exponential function, 0, 1. That one, the e to the x, u to the x, e to the negative x, between -1 to 1, so it's -1 and 1. Oh, okay, so the area between them. I wonder, should it be this one or this? Well, between them should be this two then. And you can see that they're symmetrical. So sometimes if you see that the two are symmetrical, you can just 2 times from 0 to 1, right? And which one is on the top is e of x minus e of negative x. This is a minus. dx, you can do that too. Of course, you can do -1 to 1, but it's not necessary. They're symmetrical, it's kind of. So 2 times 0 to 1. Oh, well, we can actually do it right away. We don't have anything to simplify. So that would be 2 times of e of x derivative is antiderivative is e of x minus e of negative x, but because it's the k is -1, you do divide by -1, and then we 0 to 1. So e of x, this become e of x plus e of negative x. So 2 times e of x plus negative plus e of negative x. From 0 to 1. So 2 e plus e of negative 1 is 1 over e minus e of 0 plus e of 0. Right? E of 0 is 1. So don't forget e of 0 is 1. So be 2 or 2 times of e plus 1 over e minus 2. So be 2e plus 2 over e minus 4. So that's the exact value. Let me check with the calculator. Yes, that's the right answer. You can use your calculator to check the exact value. Now, I want to just talk about, like, if you are to do two separate one, you can see that from the left-hand side, e of negative x is on top, but e of x in the bottom. So technically, you can do a if you're not sure that they're symmetrical from -1 to 0, but it would be e of negative x minus e of x, right? Plus from 0 to 1, that one we will have e of x minus e of negative x dx, that way. And if you do this, it should be the same as this one. Okay, so in the next video, we'll talk about area of complex region, and also when the region is defined with respect to y. That means the region is in the interval of y because our curve are given as x equal to a function of y. Yeah, so we can do it by dy instead of dx. So that would be the next video.